Okay, so let's look at the first part. Okay, so I see that they give us a graph of 1 over x. And then they have this region R from 1 to K. K is greater than 1, so it's going to be to the right of 1. And they want us to find first the area of the region R. Okay, so again, when we're doing anything with an area of a region above the x-axis, you could do an integral, 1 to k. And then in our case, it's going to be our function, 1 over x dx. So here we get ln of x from 1 to k. So it's ln k minus ln 1, which is going to give us ln k because ln 1 is 0. All right, so part B, it says write the integral. Do not evaluate, write the integral, do not evaluate expressions in terms of k involving one or more integrals that gives us the perimeter of that region. Okay, so if we're looking for the perimeter of that region, okay, you have to think about everything that is given, right? So we're looking for all the way around, okay? And so a couple things that are pretty easy, right? Like the distance between 1 and this function, right, which remember would be 1 over x. If you plug in 1, you get the height of 1, okay? The difference here, right, would be k minus 1, and the height here would be 1 over k. So right there with the perimeter, I know it's 1 plus k minus 1 plus 1 over k, plus now we have to find this distance here, which if you think about it, this is arc length, right? Okay, so when you're doing arc length, you're doing the integral, so from 1 to k, okay, and then we are doing the square root of 1 plus, I'm going to put it this way, y prime squared, right? So the derivative of our function squared, and then dx. So for us, our derivative of our function, right, is going to be negative 1 over x squared, okay? So here we wind up getting, if you combine like terms, right, 1 minus 1 is just going to be 0, so it's k plus 1 over k plus, now I'm just going to plug in y prime there. And then simplify it one last time. And this becomes x to the 4th, and then dx. Okay, so that would be your answer for the perimeter of that region, okay? All right, the last part you have is part C. It says, region R is rotated about the x-axis, okay? So rotated around the x-axis to form a solid as k increases without bound. So once you hear k is increasing without bound, you know that for letter C, k is going to infinity. All right, we want to know, find the volume of the solid, or show that the volume is infinite, right? Okay, so either it's infinite or we're finding the volume. So what you wanted to do here was, if you go back to our graph, Okay, it's still the same idea, but now since we're revolving around the x-axis, okay, our integral setup is going to be pi, right? 1, right? Because we're going from 1 to k, and then it's 1 over x, the whole thing squared dx. So I'm just using disk method here. Okay, so now we could write it as the limit as k goes to infinity, pi 1 over k, 1 over x squared dx, like that. And now when you simplify this or evaluate, right, so we're going to do the antiderivative of 1 over x squared, which is going to give me a negative 1 over x. If you're unsure, rewrite it this way, right? And then you could see when you do your anti, you're adding 1 and dividing by that number. So that's how I got that value down there. Now I'm going to evaluate from 1 to k. So let's plug in. Negative 1 over k minus, which will become a plus 1, right? And you could see as k goes to infinity, right, this whole term is going to 0. So you're just going to be pi times 1 or pi as your answer.